last lecture we had talked about the notion of pointers, and we saw that essentially a pointer is the address of a variable, and we saw the two operators which are related to pointers, that is the ampersand operator, which given the operand as a variable is gives the address of that variable, and the star operator or the pointer dereferencing operator, which given a pointer value as an operand gives the contents of the variable or the location to which the pointer points. So today we will continue our discussion on pointers by exploring the relationship between arrays and pointers. In C, there is a very close relationship between arrays and pointers, and as we will see, in some cases arrays and pointers can be used interchangeably. So to begin with, consider the following two declarations. Int a20, so we are declaring an array called a of 20 integers, and then we are declaring a pointer variable p, which is of type int star, and the initial value of p is nothing but a. Now in C, the expression a itself, where a is the name of an array, is nothing but the address of the 0th element of the array, and therefore the expression a and the expression ampersand a0 are completely equivalent, which means that in this initialization, p is being initialized to point to the 0th element of the array a. So in terms of pictures that we saw last time, which help us understand pointers better, so p is pointing to the 0th element of the array a. So essentially what we are saying is that the expression a itself, where a is the name of an array, is the same or is equivalent to the address of the 0th element of the array. Now recall that in C we said earlier that the different elements of an array are stored at contiguous or adjacent memory locations. So for example, if the first element or the 0th element of the array a is at memory location 1000 and each element requires 4 bytes, then the first element would be at memory location 1004, the second element would be at 1008, and so on and so forth. So essentially viewed in that sense, the expression a gives the starting address where the array a is stored in the memory. And similarly, you can see that since a and ampersand a0 are equivalent, so are star a and a0. This is because star of ampersand x is always equivalent to x, right? Because we are first taking the address of the variable x and then we are dereferencing that address. So this is always true, and so therefore star of ampersand a0 must be the same as a0, and this is nothing but a, so therefore what we get is that star a is same as a0. Note that what this means is that though star a can appear on the left hand side of an expression, of an assignment expression, which will mean that the 0th element of the array a is being assigned some value, the expression a itself cannot appear on the left hand side of an assignment, because that would mean that the starting address of the array a is being changed, which is not possible, of course, because as we saw last time, the addresses of variables are fixed and they are assigned by the compiler. We cannot change them, but when an address is stored in another variable, then the contents of that variable can be changed. Okay, now the next important thing to understand is that even a pointer can be used using the array notation, that is dereferencing using a pointer can be done even using the array notation, provided that the pointer does point to an array. So let's take a simple example. So we have two declarations here again. A is an array of 5 elements, so that is how it is depicted, and p is a pointer of type int star, which means that this variable p will hold a pointer to some integer. Now the first assignment that is there is p assigned a. So what happens when this assignment executes? the address stored in the variable p is nothing but the address of the 0th element of A. Now when A2 is assigned 3, now that's familiar to us. What should happen is that the second element of array A will get the value 3. But now what is interesting is that we could use the variable p as if it is an array, and that is because it is pointing to an array element. So when p3 is done, that would be the same as a matter of fact A3 assigned 5, because p and A are synonymous in the sense that the value of value of the variable p is nothing but the starting address of the array A. So when p3 assigned 5 is executed, the third element of the array A is assigned the value 5. This will become hopefully more clear using more examples that we'll see as the lecture progresses. Now we can also pass arrays as arguments to functions, and in fact we have been doing that in the case of some library functions. For example, we saw the string functions in the standard C library, for example, functions to find the length of a string and so on. So there, when we pass a string as an argument, as you know, a string is nothing but an array of characters with the special property that it is terminated by a null character. So what we are passing to the string length function is really an array. So what we want to next explore is what happens when arrays are passed to functions, and how do we define such functions, and how do we call such functions, and so on. So let's take a very simple example. Suppose you want to write a function to search for a given element in a given array. So let's say we are given an array of integers, and we are given the number of elements in that integer, and we are given a particular value, and we want to search in the array for that value. And if the array contains that value, then we should return, this function is supposed to return the index at which in the array that value is present, and if that value is not present anywhere in the array, then the function should return -1. Okay, so here is what the function would look like. Note that n and e are integer parameters as usual, so there is nothing special about them. N is the actual number of elements in the array which is being passed, and e is the value that we need to search for. Now this is the array itself which is being passed. So what's going to happen in C is that when an array is passed as an argument, what is actually passed to the function is nothing but the starting address of the array. So the argument A here actually denotes nothing but the starting address of the array which is being passed as an argument. So the function itself is quite simple. So we have a for loop, and we examine all elements of the array A from 0 to n minus 1, and if for a particular value of I, ai happens to equal e, then we immediately return I, because at the array index I, the array A contains the value e. Note that the return statement would not just break out of the loop, but would immediately cause the function to return. So the next statement would not execute in that case. So that means that if the array element that the value e was found somewhere in the array, then this loop will not finish as a matter of fact, and this return statement will cause the function to return before the loop finishes. And so if the loop does finish, that implies that the array did not contain the value e at any place or at any index, and therefore we should return the value -1. So the important point to note is that the value of the parameter a in this function is nothing but the starting address of the array which is being passed as an argument. A copy of that array is not being passed, and that also means that when we declare this array, we don't need to specify the size of the array. The reason is that when the memory is allocated for this parameter a, the amount of memory required is the amount of space needed to store just one pointer value or just one address, and so therefore that does not depend on how many elements in the array that is being passed as an argument are there. And because of this reason, in fact, uh, we could have written this function slightly differently, and instead of declaring a in this fashion, we could have declared a in this fashion as well. And even then, the rest of the code of the function would not need to change, because as we just saw, even a pointer value can be used as an array, right? So let's see now how this function could be called from some other function, let's say the main function, though that's not important, it could be called from any function really. So in this example, we have two arrays, A1 and A2, of size 100 and 200 respectively, and some code initializes the values of the elements of the arrays A1 and A2, and also the values of the variables N1 and N2. So let's assume that A1 has N1 elements and A2 has N2 elements, and we could use the same function search to search for some value in both of these arrays. The fact that the sizes of these two arrays is different does not really matter, because the actual size of the array or the actual number of elements in the array is being passed as an argument, and when the array itself is passed, then what is being passed really is only the starting address. And that should be clear also from the rule about that we talked about earlier, about how arguments are passed to functions. So the argument A1 would be evaluated in that case, and we just saw that an expression denoting just an array name evaluates to nothing but the starting address of the array. So the expression A1 evaluates to just the starting address of the array A1, and that is passed as argument to the function search. And similarly in this case, the starting address of the array A2 is passed as argument. Okay, let's consider now another example which modifies the array in which the function which is given an array as a parameter actually modifies some of the elements in that array. So let's consider a very simple example again, in which we are writing a function which is intended to double the value of every element of an array. So here is what that function might look like. Double array is the name of the function. There is no return value, and so the return type is void. The argument is an integer specifying how many elements are actually there in the array A, which is being passed as the first argument. And the code is very simple. For all elements from 0 to n minus 1th element of the array, we just double the array element using the star equal to operator. But the question is whether the change is visible in the calling function, that the values of the array that we have changed here in this function in the various elements of the array, is that change visible in the calling function. Recall that when we modify, let's say, an integer parameter within the function, then if the actual argument happened to be a variable in the calling function, then the modification to the parameter does not cause a modification in the variable which was passed as argument to it, because as we know, a copy of that variable, of the value of that variable, is made available to the parameter. But in the case of arrays, recall that it is the starting address of the array which is being passed as an argument, and not a copy of the values of the elements of the array. So therefore, when this change is being made to an array element, what is actually happening is that the array element of the original array which was passed as argument, that is being accessed by using its address, and therefore the change would be visible even when the function returns to the calling function. So let's try to clarify that situation with the help of this example, where I have put the same function in the context of a calling function. So let's assume that this function double array is being called from the function main, which has an array A of 5 elements and an integer variable I, and this loop initializes all array elements of A from index 0 to 4 to 1, and then it calls double array with A and 5, the number of elements in the array, as the argument. Now when this function call happens, so this variable A is the variable a of the main function, and which represents this array of 5 elements, each of which has the value 1. And when this is passed as argument to this function double array, so the parameter there is also called a, but what this parameter will contain will not be this parameter a will not refer to an array itself, but a pointer to the 0th element of the original array which was passed as argument. So now when this function executes, let's say when this statement is executed for the value of I equal to 0, which means that a0 star equal to 2 is executed. Now what does a0 really mean? A0 means the 0th element of the array to which the pointer a is pointing. Note that in the context of this function, this a is not really an array, but it's a pointer. So a0 would refer to the 0th element of the array to which the variable a is pointing. And so when this assignment is executed, the 0th element of the original array a is modified to 2. And similarly, in the next iteration of the loop, this statement will be executed, and a1 will refer to the first element of the array to which the variable a is pointing, which is this one, and so this will become 2. And so finally, when the function double array returns, this variable a will be destroyed, and the control will go back to main. But in the main function, note that the value of the array elements in a have actually changed. Right. So essentially, what is happening is that when an array is passed as a parameter to a function, it's the starting address of the array that gets passed, and in the called function, if some array element is modified, then because this value is being modified using the address of the memory location containing this value, the change is visible even when the function returns to the calling function. Now this is different from when a normal integer variable is passed, because when a simple integer variable is passed, the parameter gets a copy of the value of the argument, and if that parameter is changed within the body of the function, then that change is not visible in the calling function. Okay, let's now come to another related notion, and that's the notion of pointer arithmetic. You might be surprised to know that in C you can actually do some arithmetic with pointers. The arithmetic which is allowed with pointers is very limited. You can add or subtract integers to or from pointers. That is, you can add an integer to a pointer, or you could subtract an integer from a pointer. Now this makes sense only when the pointer actually points to some array element of some array. So for example, if p points to the ith element of some array a, then p plus j, where j is an integer, points to the I plus jth element of the same array a. And similarly, p minus j points to the I minus jth element of the array a. Note that it is possible that p is not pointing to an array at all, or maybe when p plus j is done, the array actually does not have I plus j elements, or maybe if p minus j is done, the value of I minus j happens to be negative, which means again the array does not have an element at that particular location. So the computation of the pointer resulting from the pointer arithmetic will work, but when you try to dereference such a pointer which has resulted from this arithmetic, that will cause unexpected results, and that will be similar to an array element being accessed with an index which is out of bounds. So for example, if an array has n elements, and if you try to access the nth or the n plus 1th element or the minus 1th element, then that's an error and results in unpredictable behavior. And similarly, if you try to obtain a pointer to the nth or n plus 1th element of the array or the minus first element of the array, you can obtain a pointer, but when you try to dereference it using the star operator, then the results will be completely unpredictable, and therefore it's our responsibility to make sure that this never happens, that whenever we do the pointer arithmetic, we always make sure that our pointer is pointing to a valid element of the array. So let's see an example of pointer arithmetic now. So in this example, we have two again variables. A is an array of 5 elements, and P is of type int star, which means that P will contain a pointer to an integer. Now the first assignment that happens is P assigned a plus 1. Now what do you think will happen? Note that the expression A denotes the starting address of array A, or in other words, the address of the 0th element of A. And now if you add 1 to it, 1 is an integer, if you add 1 to the address of the 0th element of A, what you get is the address of the first element of A. So once this assignment executes, P will point to the first element of the array A. Now in the next step, we have the statement P plus equal to 2, which of course, as you know, is the same as P assigned P plus 2. So in this case, again, what we are doing is adding 2 to a pointer value and assigning the result back to the pointer variable P. Now P is currently pointing to the first element of the array A, so P plus 2 will point to the third element of the array A, and that pointer value is assigned back into the variable P. And so after execution of this assignment, P will point to the third element of the array A. And in the next step, we are subtracting something from the pointer. We are subtracting 1 from the pointer, which means that the pointer will move one step back in the array. So P will now start pointing to the second element of the array A. Now we are doing something interesting. We are using P as an array, and we are dereferencing some pointer using the array notation. But note that P is not actually pointing to the 0th element of the array. It is pointing to some element of the array, but that doesn't really matter. When we say P1 assign 5, what's going to happen is, think of an array which starts here. So think of just this section of the array. So when we are using P as an array, where P is pointing to some ith element of the array, then P1 is the same as Pi plus 1 if P is the same as, sorry, this is Ai plus 1, if P is the same as which is of course the same as A plus I. So if P points to the ith element, then P1 would refer to the I plus 1th element of that array. So therefore, now when P1 is assigned 5, what will happen is that the first element of this array segment will become 1, and so P1 would be this particular cell, which, as you can see, is the third element of the array A, and that follows from this kind of rule that we just saw. Since P is pointing to the second element of the array, then P1 is the same as the 2 plus 1th, that is the third element of the array A. So P1 assigned 5 results in this element of the array A getting the value 5. Okay, let's now again talk a little bit about strings and see how strings relate to arrays. We already know that strings are actually arrays of characters, with the special property that the useful data in the string is terminated by a null character. And as a matter of fact, strings are very commonly used as pointers, because as we have already seen, arrays can be used as pointers. So whenever in a function like for example printf, we pass a format string as an argument, or in a function like strlen, we pass a string as an argument and returns the length of the string. When we pass a string as an argument to a function, what we are really passing is the starting address of the character array that stores the string. And this follows just from the fact that the string is really nothing but an array, and when we pass an array as an argument to a function, what is really passed is the starting address of the array. Now, strings are also different from other kinds of arrays in the sense that it is possible to have constant strings. For example, the constant string ABC here. Now, what kind of an array is that? Now, what happens with constant strings is that the constant strings are treated by the compiler as anonymous arrays. Anonymous means without a name. So, when we use a constant string in the program, what happens is that the compiler creates some space somewhere in the memory which contains that string, and the value of the constant string expression is nothing but the starting address of that array. And we should be careful here that different declarations, different ways of declaration of a string may actually mean different things. So now that we know that pointers and arrays can be used interchangeably, we could have these two different kinds of declarations for a string variable, but the behavior is going to be slightly different in these two cases. So in the first case, we are declaring a pointer variable p, which is initialized to the starting address of a constant string ABC. In the second case, we are declaring an array of characters called p, which is being initialized to the string ABC. So in the first case, if we draw this in terms of pictures, what it looks like is the following: that ABC is an anonymous array created in the memory somewhere by the compiler, which contains the string A, B, C, the characters A, B, C, followed by, of course, the null character, and the variable P, a box is created for the variable P, or its memory location is assigned for the variable P, and that is initialized to point to the starting address of this anonymous array. Note that in this case we can change the value of the variable P, because P is a normal variable of type cat star, and we can reassign it to point to some other string. Now, if we contrast it with the other kind of declaration, what is happening in this case is that we are asking the compiler to create an array called P. It's no longer an anonymous array, which is initialized, which will have 4 elements in it, because the size of the initializing string is 4, including the null character. And so P is the name of an array whose elements are the characters A, B, C, and the null character. Note that now P is the name of an array, and therefore P cannot appear on the left side of an assignment. So P assigned something would be wrong in this declaration, whereas P assigned some other thing would be correct in this kind of a declaration, because here P is associated with a point. P is the name of a pointer variable, whereas here P is the name of an array itself. Okay, now let's revisit some of the string handling functions that we talked about some time back, and we'll see that it is very easy to write the string handling functions that we use from the library. So as an example, let's try writing the string length function ourselves, and that will illustrate how easy it is to actually write functions that manipulate strings and so on. So as you know, the functionality of the string length function is simple. Given a string, we have to return its length, and to do that, all we have to do is we have to count the characters in the string till we find a null character, and this count is the length of the string. Note that the length that we have to return should not include the null character itself. So here is the first version of our string length implementation. So we are actually using the pointer which is passed to the function as an array using the array notation. So this loop initializes I to 0, and then as long as si is not equal to the null character, it increments I. Note that the loop body is empty, so all that is happening is in this I++ and in the loop condition. So essentially this loop will terminate as soon as we find that si is equal to the null character, and then I will be nothing but the length of the array, because note that we are incrementing I once for every non-null character that we find in the string. Now we could have written the same string handling function, the same string length function, using pointer arithmetic as well. That is, instead of using si to access the ith element of the string, ith character in the string, we could have used something like star of s plus I, which would be the same as s of I. So we could have done that, and even more interestingly, we could have modified the value of the variable s itself in the loop. So let's look at this second implementation of the same function. So this time I have chosen to declare s as a char star, which of course is the same as declaring it as an array within the function parameters. But I am going to use s as a pointer and not use it with the array notation. So in this version of the function, what is being done is that again I is assigned 0, that will be the count, and we are checking whether s is pointing to the null character. Now star s is nothing but the value of the character to which s points, and as long as that is not null, we keep running the loop. The loop body is again empty, but after every iteration of the loop, we increment I by 1, of course, to account or count for the non-null character that we have just seen, and we also increment the value of s. Note that this is the same as s assigned s plus 1. Now this is not normal arithmetic, this is pointer arithmetic, because s is a pointer. So what we are doing here, interestingly, is that we are modifying the pointer argument that has been passed to us. But again, note that it is the copy of the address that we have been given. We are not actually modifying an element of the string whose address is given to us, but the address of the string itself. And the address of the string that we have been given is actually a copy of the original address from the calling function. So the change to s will not get reflected in the calling program. Now this may not be obvious to you, but once we trace this function with a calling function and with the help of the notation that you have already seen using boxes and arrows to represent variables and pointers, this will become very clear. So let's go and do that. Okay, so here is the same function again, the string length function that we had just seen, and let's say this is the calling function. So in this calling function we have a pointer p which is pointing to a constant string ABC. So let's draw our familiar boxes and arrows. So p is pointing to the 0th element of this anonymous array containing the characters A, B, C followed by the null character, and of course L is a normal integer variable, and then we are calling string length with the argument P, and the result is assigned to L. So these two are the variables of the calling function. Now when this function gets called, space is created for the argument, for the parameter. The parameter is s, which is just a pointer, and this will be initialized with the value of the argument which is passed. So value of the argument is the value of the variable p, which is a pointer to the 0th element of the string. So the value of s will also be this. Now when this loop runs, I is initialized to 0. I is a local variable of the string length function. So I gets initialized here, and s is already pointing to the 0th element of the string. Now the check is made whether star s is equal to the null character or not. Star s is nothing but the character A, which is not the null character. So the loop body executes. The loop body itself is empty, and at the end of the loop body, this expression is evaluated. Note that it is using the comma operator, which means both these expressions will get evaluated. So the first expression to be evaluated is s plus plus, which will mean, which is of course, as we saw, is the same as s assigned s plus 1, which will mean that s will now start pointing to the first element of this character array, and I will become 1. Now the next time the loop condition is again tested, star s is now b, which is still not the null character. So s gets incremented again. S starts pointing here, and I is incremented, so I becomes 2. And then we again go back to the loop test. Star s is still not equal to the null character, so the value of s is changed to point to the next element in the array, and the value of I becomes 3. And then the loop test is executed again. This time star s is the null character, and which is, so this test fails, so the loop terminates. And when the loop terminates, we come to this return statement, which returns the value of I, which is 3, which is the correct length of the string, of course. So the value 3 is returned, but now the variables of the string length function will get deallocated, and the control will go back to the calling function. So L will get assigned the return value, which was of course 3. And the important point to note is that the modification of S has not resulted in the modification of the variable of the value of the variable P. The variable P is still pointing to the 0th element of the original array. Now on the other hand, if we had modified an element of the array itself, so for example, if we had executed a statement like this, let's say x, and let's say at that point in time s happened to be pointing to the first element of the string, then this would have been modified, and even when this function returned and s got deallocated, this change in the string would still get reflected. But here what is being modified is just the address which is being passed to us, and since we have gotten a copy of this address, this local copy within the string length function is being modified, and the original copy of this address does not get modified. So that's the end of this lecture today, and before we stop, I would like you to utilize the techniques that we have discussed today to try and implement some of the other string library functions that we have already used in some programs. For example, you could implement the string cat strcat function, which concatenates two strings, or you could implement the string comparison function strcmp, which compares two strings in the lexicographic order.